Next, we're going to talk about volume to volume conversion problems. So let's remind ourselves again of the steps to calculate any stoichiometric problem. Step number 1 is to correctly balance the equation. Step number 2 is to convert the given amount into moles. Step 3 is to set up the mole ratios, and step 4 is to use those ratios to calculate the moles of the desired chemical. Step number 5 is to convert the moles back into the final unit. Even though there's 5 steps here, remember this really equates to 3 brackets of math problems. So here's an example problem. How many liters of CH4 at STP are required to completely react with 17.5 liters of oxygen? So here's our balanced chemical equation, and we're going to start with the one piece of information they gave us in the problem, 17.5 liters of oxygen. So remember, 1 mole of any gas at STP is 22.4 liters of volume. So liters of oxygen, we'll cross off with liters of oxygen, and our first bracket is step 2 actually. We converted to moles of the chemical. We have moles of oxygen now. Steps 3 and 4, our middle bracket here, we're going to use the mole-mole ratios to get away from moles of oxygen. We're going to cross that off, so we'll put that on the bottom. We want to turn it into moles of CH4. So there's no number there, but it's really a 1. So now moles of O2 will cross off with moles of O2, and we're now into moles of CH4. I don't want moles of CH4, I want liters of CH4. So my last step is to convert from moles of CH4 to liters. Remember, 1 mole of any gas, like CH4, at STP is 22.4 liters of volume. So now moles and moles of CH4 will cross off. I'm left with liters of CH4, and it's time to go to my calculator. 17.5 divided by 22.4 divided by 2 times 22.4 is 8.75 liters of CH4. But did you notice anything about these two steps here? They are inverse of one another, so they would cancel out technically. 1 mole of O2 will cross off with 1 mole of CH4, 22.4 liters of O2 it will cross off with 22.4 liters of CH4. So if this happens, if you have two steps that are inverse of one another, they cancel each other out. So they're really not necessary. We can get rid of them and shorten it to this. So in a volume-to-volume problem, all you have to do is multiply by the molar ratio and you'll get the answer correct. This will save you a little bit of time. So remember, equal volumes of gas at the same temperature and pressure contain the same number of particles. And moles are a number of particles. A mole is really Avogadro's number of particles. So you can treat a gaseous reaction, that means if everything's a gas and it's at STP, you can treat that as if they happen liters at a time as long as the temperature and pressure are the same. STP conditions, they'll likely be. So instead of moles of CH4, we can say this reacts 1 liter of CH4. And instead of 2 moles of oxygen, we can say 2 liters of oxygen. If you want your units to be the same, they'll cancel a little nicer like this, but the answer is still the same no matter which way you do it. Again, this shortcut only works for a volume-to-volume problem, but you can use it if you'd like. So to solve a volume-volume problem, follow the 5-step approach that you do in any stoichiometric problem. Remember, 1 mole of a gas at STP is 22.4 liters. That only works if it's a gas and that gas is at STP, but it most likely will be for these types of problems. The first bracket in any volume-volume problem is to divide by the molar volume, divide by 22.4. The second bracket is to use your mole-mole ratio step, and the third bracket is to multiply by the molar volume. But again, if you want to skip the first and third bracket, you can. You can just multiply by the mole-mole ratio, and you'll get the answer right.